It is started.
So this is a 4-bar linkage with the triangular link 3. We want to find velocity and acceleration of all elements, omega 3, omega 4, alpha 3, alpha 4, velocity acceleration of E. And the dimensions are kind of a scale. The lengths are given here. And omega 2, link 2 has omega and alpha of 2.5 and 1.5. So we're going to start with velocity, right? So when we do the velocity, the first step is to write the equation. I mentioned always that when you want to do this, you have a couple of links with a certain type of motion, either circular or translation. If you have slider, you pick the link with general motion. Usually link 3, and you can distinguish whichever the numbers may change. You pick the link with general motion. You have information about one end of the link, which is B. You have velocity acceleration from link 2, and then you relate it to 3. So what I'm going to do is this, to write VC, I'm going to relate C to B. So VC is VB plus omega BC cross R C respect to B. So I need to find VB because omega 2 is given. We can calculate that. So I'm going to write it here. VB will be RAB omega 2.
Yep.
You calculate the numbers for me. And we know that VB is also perpendicular to RAB.
Is RAB 4?
4, yes.
Okay, so that makes 10.
Is it going to be 10 centimeter per second. And VB is perpendicular to RAB. So I put my reference point here as O prime. Then I will draw a line perpendicular to this from O prime. So one way to do it is to make this kind of like a slider, come here and draw a line. Because omega is this way, velocity of B has to be this way.
Yep.
And I'm going to use the scale of 1 centimeter for 2 centimeter per second. Which means 10 centimeter per second will give me 5 centimeter of the vector VB. So it's going to be here, and I will erase the rest.
Okay.
Now, I have got this velocity term. About this term, I know omega BC cross RC respect to B is perpendicular to BC or RBC, right?
You know that the movement of
This term, because
Yes.
it's a cross product, is perpendicular to this link.
Yep.
And it has to be added to VB. So I will draw a line from end of this perpendicular to this term. And that's how we can do it. If we get this, and if we get this, then we draw a line from end of VB.
And you do it from the end because you're constructing it. You're
Yes,
constructing
because
BC
we
from-
add
yep,
these two
yep.
vectors together, so you have to do it from end of that one. So, and you're gonna have a line like this, which could be either way. Now, from the, so I drew this, of course not the magnitude, but
Yeah.
the direction. From VC, I do not know the magnitude, but
you know the
C
direction.
rotates about a fixed
D.
point D, which is circular motion. So VC is perpendicular to RCD, right?
So you will draw a perpendicular line from the origin.
From the origin, because it's the other side of equal sign. So I will draw a line perpendicular to this from this base. And to do that, I use this as a guide so I can slide this back and forth, right? So when I do this, I draw my line like this. And this triangle is constructed here. This is going to be my VC. This was already my VB. And this term will be
omega BC.
omega BC RBC. I can call this point as B prime, this point as C prime. If I want to find omega 4, because VC is equal to RCD omega 4, then omega 4 will be VC over RCD, right?
Yeah.
So I have VC, I can measure it and scale it back to the number. So this looks like 4.4 centimeter. So my VC is 4.4 times 2, which is my scale. It's going to be 8.8 centimeter per second. Therefore, my omega 4 will be 8.8 divided by 6.
You want a fraction?
No, it's okay. Which is going to be 1.47 radian per second. If I want to find omega BC, I'm going to have to measure this length and then divide it by RBC. So this length is going to be fairly 3.5. So omega BC RBC is 3.5 times my scale, which is 2, and it's going to be 7. So my omega BC is 7 divided by RBC, which is 7.